Hey guys, still on lesson 7.1. I'm going to finish task 2. The video cut off in the middle of this on the last one. So part C, the relationship between inverse functions can be visualized by graphing both functions on the same coordinate grid. Use the graph of g inverse of x to find g inverse of 0 and g inverse of 4. Alright, so if you look here, g inverse of 0, so g of x, so we're looking at the x part, so it's going to be negative 2. So when x is 0, y is negative 2. And then we want to find g inverse of 4. So when x is 4, y is 0. All right, and you can see the relationship here. This is g of x, and then the blue line it shows is g inverse of x. So when you switch the x and y's, that's what you get for the new function. All right, it says, what relationship do you see between the graphs of g of x and g inverse of x from part C? All right, so there's this imaginary line here. This dotted line is y equals x. That means it goes through the origin. The y-intercept is 0, and it has a slope of 1. So y equals x. And again, to find the inverse, you switch the x and y. So that's why it's a reflection over that line. So they are reflections of each other across the line y equals x. All right, that's all for task 2. If you have any questions, let me know. All right, guys, we're going to look at a couple examples, and we're going to use composition of functions to verify the functions are inverses. So the first thing we're going to do is find the inverse. So you're going to switch the x and y. Okay, so let's first rewrite this as y instead of j of x. So let's write this as y equals 3/5 x plus 10. And then we're going to switch the x and y. Okay, so when you solve for the inverse, you switch those. So we're going to say x equals 3/5 y plus 10. And then we're going to solve for y. So we need to subtract 10 from both sides. And then multiply by the reciprocal of 3/5. So the reciprocal of 3/5 is 5/3. And you're going to multiply this whole side by 5/3. Now the reason we do that, a fraction means you multiply across the top and across the bottom. 15 over 15 is just 1, so that leaves just y equals. You can leave it like this, or you can distribute 5/3. 5/3 times x and 5/3 times 10, so that would be 50 over 3, so minus 50 over 3. All right, and again, you can leave it in this form as well. All right, once you get to here, this is the inverse of j of x. So you can write that as j inverse of x. So we switched it to y just to make it easier to switch places. But then once you get to the end, let's leave it as 5/3 times x minus 10. All right. Now, the question didn't say find the inverse. It said use composition of functions to verify the functions are inverses. All right, so what that means is we have to plug a number into one function and then take the output, plug it into here. And if we get the number we started with, that means these are inverse functions. So that means we have used composition to prove or verify that they are inverses. So it's always nice to choose just an easy number. So let's say let x equal 0. Just pick a number, 0, 1, whatever you want to pick. So let's take 0 and plug it into j of x. So if we do j of x, we're going to have 3/5 times 0 plus 10, and that's going to equal 10. So we're going to take 10 and we're going to plug it into the other function. So we're going to take j inverse of x, and we're going to have 5/3 times 10 minus 10. Well, 10 minus 10 is 0, and 5/3 times 0 is 0. So we let x be 0. We plugged it into one function, took the output, plugged it into the other function. We got what we started with. So that means these two functions are inverses of each other. All right, let's look at one more example. All right, so again, we're going to start by finding the inverse. So y equals 3x plus 1. I'm going to switch x and y. X equals 3y plus 1. I'm going to subtract y from both sides. X minus 1 equals 3y. And divide everything by 3. So y equals x minus 1 over 3. Now, this is now my inverse function of what we started with. So that's f inverse of x. This is the notation that you're going to learn to use all the time for inverse functions. So that's going to be x minus 1 over 3. All right, so we have one function here, we have a second function here, and we want to use a composition of functions to prove or verify that these are inverses. So if we did this correctly, it should work every time because we're trying to prove that this is the inverse of this. All right, so again, you can choose any number you want. I'm going to choose 0 again because that's an easy number to substitute in. So we're going to say f of x equals 3 times 0 plus 1. So that equals 1. So we're going to take f inverse of x, and we're going to say 1 minus 1 divided by 3. So f inverse of x, 1 minus 1 is 0. 0 divided by 3 is 0. So we let x be 0, plugged it into one, plugged the output into the other one, and got 0. So this is the inverse of this. All right, so that's how you find inverses, and that's how you use composition of functions to verify two functions are inverses. If you have any questions, please let me know.